Hello guys, welcome to the first tutorial on trees. Today we are going to discuss on trees, binary trees, post order, pre-order, and in order. The first thing you need to know is that trees are hierarchical data structure that are used to store data in a computer. Binary trees is among the most common type used in the computer data storage. Mostly binary trees are also used to implement some programming approaches, and therefore it is very important for you to have the basic knowledge of what is a tree and what is the difference between a tree, a binary tree, and different approaches on how we are able to group the trees. So a tree, for example, the first example we have here, we have the A, B, C, D, E, F, and G. The first example, you find that it is a tree, but this is not a binary tree. Remember, a binary tree, like explained just below here, should have only two children. So this one has this is the root, A is the root, B is a child, C is a child, and D is a child, and therefore it has more than two children. So that is not a binary tree, it's just a tree. Now let's go to binary tree, which is our focus today. Binary tree are a logical model where every node can only have at most two nodes, as I've said. Binary tree, we can say also that they are finite element that is either empty or partitioned into three disjoint sets called root, left, and right. So you find that the binary tree has only two children, that is left and right, while the topmost is the root. Some of other definitions in a binary tree, we have leaves. A leaf is a node with empty left and right subtree. Then we have types of binary tree. We have strict binary tree, where all non-leaf nodes have both left and right subtree. We have complementary binary tree of depth D. We can say that it is a strict binary tree where all the leaves that are at the level node are filled with the left being filled. The right node must not always be filled. So you find that a complete binary tree has some relationship with a strict binary tree, only that on one side the right node must not be complete. So we can say that a complete binary tree has a depth D of D has 2D minus a node. Obviously that is where we shall get to know how to calculate the same. In an almost complete binary tree is where every leaf is at the left, is at level D, or D at D minus 1. Every node with a right descendant at level D has a left descendant at level D. And therefore the last one we have is perfect binary tree, where we say it is 2 raised to power 1 plus 1 minus 1, where all levels are completely filled. Now in order to construct a binary tree, we always need the following operations. One is to make sure that we have we'll make a tree, that is, we create a new binary tree with a single node, add excuse, and return a pointer for it. Then we have set left, that is p comma x. Then we can say that we create a left sun for p with info field x, so you find that p is a pointer. Set light px, we create a right sun for p with info x. Then we have tree traversal. Traversing a tree means visiting each node in specific order. So we are trying to either do a search in a particular tree, and therefore we have two major types of traversing a tree. We can either do breadth first or do deep first. In deep first, we have three major types of traversing a tree, that is preorder, in order, and post order. In preorder, we say that we shall first start with root. Then if the root is already taken care of, then we shall pick left. If left is already taken care of, then we can pick right, and therefore we can call that as PLR, that is parent, then left, then right. In order, we start with the first, we start with left, then parent, then right. So that is the order. You have to start with left, then parent, then right. Then we have post order. For the first, we do the left, left, then right, then parent. Now, if we check on what is when we talk of breadth first traversal, is a situation where we first start with the going along the tree. So if we have like the example below here, we shall be able to find it very well. So we can say that we perform a breadth traversal on an empty tree. First we access the root, then the children of the root from the left to the right, then the grandchildren always from left to the right, and so on. So if we have this tree below here, it's good to note that this is the root, and the others are the children. We have B, C, D, E, F, G, and therefore we can also call H, I, J, K, F, G.